This is Euclid Book 10, proposition number 97, and it says the following. The square on an apotome applied to a rational straight line produces as breadth a first apotome. Let AB be an apotome. This is an apotome right across here. And let CD be rational. Well, CD is a rational line right there. And to CD, let there be applied CE, which is this area right here, CDEF, this area right here, equal to the square on AB. Now, where do we get the square on AB? We take the length of AB, we turn it into a square, and all four sides of that square are going to be the length of AB, so we're going to represent that with this right here. Okay, so we're going to say, hypothetically, this area here is equal to this area here. Okay. Now, we're going to produce CF as the breadth. There's CF. I say that CF is a first apotome. Now we're going to declare through this proof that this is a first apotome. For let BG be the annex to AB. Okay, so BG is the annex to this. Therefore, AG and GB, okay, this is line AG across here, and this is BG right across here. Both of those lines are rational straight lines. They are only commensurable in square. This is by Euclid Book 10, proposition number 73. To CD, we got CD right here. Let there be applied CH. Well, what is CH? Well, that's from here to here. Okay, C, D, H, K. All of this across here. It's this area and this area and this area together. Equal to the square on AG. Now, where do we get the square on AG? Well, we take this length right across here, we make a square out of it, and all four sides of that square are going to be the length of AG. Okay? And we're going to represent it right here. Now, we're also going to apply KL. That's this area right across here. And this area is going to be equal to something. What is this area going to be equal to? Okay, we're going to take line BG and we're going to turn it into a square. And all four sides of that square are going to be the length of BG. We're going to represent it right here. So this area is going to equal this one. Okay. Therefore, the whole CL, well, what is the whole CL? That's this plus this plus this plus this. All this put together is equal to the squares on AG and GB. So what we're going to do is we're going to add this to this, okay? And these two areas combined are going to be this, 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 and this. And in these, CE, what is CE? That's this right here, is equal to the square on AB. This is equal to this. Therefore, the remainder FL. Okay, what is FL? That is this plus this plus this. All three areas here to combine. That's FL. It is equal to twice the rectangle AGGB. Now, where did we come up with the rectangle AGGB? Okay, so what we did was we took this line here. Two sides of this rectangle are going to be the length of AG. The other two sides of this rectangle are going to be the length of this. So, what we're saying here is that if you take this area, you multiply it by 2, you get this area right here. This is by Euclid Book 2, proposition number 7. Let FM, well, what is FM? That is this line right across here. We're going to bisect it at N, like that. And let NO be drawn through N parallel to CD. So NO is going to be parallel to CD. Therefore, each of the rectangles FO and LN. Okay, well, FO is this right here. Now, what's LN? Well, LN is this. It's NOLM. This one right here. Okay? So, this rectangle and this plus this together, both of them are equal to this area right here. So, this square is equal to this. This plus this is also equal to this. Now, since the squares on AG and GB are rational, since these two squares are rational, and DM, okay, what's DM? Well, DM is from here to here. all of this combined. Now since all of this is equal to this plus this, okay, all four of these are equal to this plus this, therefore dm is rational. This whole area is rational. And it's been applied to the rational straight line CD, producing cm as the breadth. Okay, so all of this area has been applied to this line, and it produced this as the breadth. Therefore, cm is a rational and therefore cm is rational. This line from here to here is rational, and it is commensurable in length with CD. This line is commensurable with this. That's by Euclid Book 10, proposition number 20. Again, since twice the rectangle AGGB is medial, so if we take this area, we multiply it by 2, we get a medial area, and FL is equal to twice the rectangle AGGB, therefore FL is medial. This right here, okay, now FL is this plus this plus this, all these combined. Okay? Now, first thing I'm going to say is that all three of these combined is equal to twice of this. Now we can say that all three of these combined is medial. And it has been applied to the rational straight line CD, producing FM as the breadth. So we've applied all of this area to CD and produced this as the breadth. Therefore, FM is rational and incommensurable in length with CD. This line is rational and it's incommensurable with this. That's by Euclid Book 10, proposition number 22. And since the squares on AG and GB are rational, okay, since these two are rational, while twice the rectangle AGGB is medial, so this area multiplied by 2 is medial, therefore the squares on AG and GB, these two right here, are incommensurable with twice the rectangle AGGB. So, if you add this and this together, it's incommensurable with twice of this. And CL is equal to the squares on AG and GB. Okay, what is CL? That's this, and this all combined. And it's equal to these two areas combined. And FL, okay, so FL is this, and this. All this across here is equal to twice of this. Therefore, DM is incommensurable with FL. Okay? This, and this is incommensurable with this, and this. Alright. But as DM is to FL, as this whole area is to these three, so is CM to FM. So is this to this. That's by Euclid Book 6, proposition number 1. Therefore, CM is incommensurable with length with FM. Okay? This is incommensurable with this. That's by Euclid Book 10, proposition number 2. And both are rational. Therefore, CM and FM are rational straight lines commensurable with square only. Therefore, CF is an apotome. This is an apotome. That's by Euclid Book 10, proposition number 73. I say next that it is also a first apotome. For since the rectangle AGGB is the mean proportional between the squares on AG and GB, okay, so since this rectangle is the mean proportional between this, and CH is equal to the square on AG, okay, so this plus this is equal to this, and KL is equal to square on BG, okay, this is equal to this, and NL is equal to the rectangle AG and GB. So what's NL? That's this and this. And these two are equal to this. Therefore, NL, that's these two, is a mean proportional between CH, which is these three right across here, and KL, which is this. Therefore, as CH is to NL, as these three are to these two, so is NL, which is these two, to KL. But as CH is to NL, as these are to these, so is CK to NM. What's CK? Well, that's line CK right across here, and NM is this line right across here. And as NL is to KL, as this is to just this by itself, so is NM to KM. Well, NM to KM. This is by Euclid Book 6, proposition number 1. Therefore, the rectangle CKKM. Okay, what is the rectangle CKKM? Well, what we do at this point is we draw another rectangle right across here, and two sides of it are going to be CK. And the other two sides are going to be KM. Where do we get CK? It's this line right across here. Where do we get KM? It's this line right across here. So therefore, this rectangle is equal to the square on NM. Okay, so what we're going to do about NM? Okay, NM is this line right here, and we're going to draw a square right here. And all four sides of this square are going to be the length of NM. So what we're saying here, hang on. So what we're saying here is this area here is equal to this area here. And that's by Euclid Book 6, proposition number 17. That is, to the fourth part of the square on FM. Now, what is the square on FM? Well, we take the length of FM, like this. I know that's a lumpy looking square, but we take the length of FM, and we turn it into a square, and all four sides of this square are going to be the length of FM. So, when we say this, we're going to say that this area equals this area, which happens to be the fourth part of the square of FM. And since the square on AG, which is this one right here, is commensurable with the square on VG, which is this one right here, CH, well, what is CH? Well, that's this plus this plus this, is commensurable with KL, which is this. But as CH is to KL, as this, and this is to this, so is CK to KM. So is this line to this line. Euclid Book 6, proposition number 1. Therefore, CK is commensurable with KM. This line is commensurable with this one. This is by Euclid Book 10, proposition number 11. Since then, CM and MF. What is CM? Well, that's this whole line across here. What is MF? That is this line right across here. So, since this and this, since this and this are two unequal straight lines, and to CM there has been applied to the rectangle CKKM. Okay, so we're applying to CM. We're going to apply to this line right across here. The rectangle CK and KM, which is this, equal to the fourth part of the square on FM, and deficient by a square figure, while CK is commensurable with KM. Well, what's CK? That's this line right across here, and it's commensurable with this. Therefore, the square on CM, which is, we're just going to draw another square. Okay, so now we're going to take this whole length right across here, and we're going to turn it into a square, and all four sides of that square are going to be the length of CM. and it's greater than FM, this is bigger than this, by a square on a straight line commensurable in length with CM. And this is by Euclid Book 10, proposition number 17. And CM is commensurable in length with the rational straight line CD set out. This is commensurable with this. Therefore, CF is the first apotome. Wowee. That's a lot of stuff. Alright, I will tell you more in a future video. Stay tuned.